Hey, who's Fab Academy here?
No one.
Yeah, maybe I'll just message him. I was wondering where we're meeting here at EAC. It's like super interesting, like making the drawing.
Every day.
¿El qué?
Aquí si nos quedaban de estos. Ah, pues es que va a buscar, mientras pones toda la introducción, está aquí. No, como quieras. Porque va a ser más fácil. Y más limpio.
Hay que sí está cargado, así que este
Pero mientras explicas eso, vamos a
So, guys, today is really hands-on class, and like nobody's online, no? Only you.
there was some.
Okay, actually, do you hear as well online? Yes, no?
Not that well, but it's okay.
Hello? Better? Sí, la tenías aquí. So today class is a little bit hands-on and is part of the Make Club. The previous classes we were like basically learning a little bit how to move with Grasshopper, do a few geometries. You remember that we started making like bases, like simple lofted bases, no? Yes.
Yes,
no?
yes.
Yes, and you were practicing every day since then, and you are completely expert, no? So this class we jump away from Grasshopper, but we use the base of what we want. Why? Because we want to street map, we want to have a little bit of fun. So we will show you how to 3D print with paste and how we run the machines. There are different ways of running the machine. Who has ever 3D printed before? Yeah? 3D printed. Any point? Yes. So you know there are different technologies. The most common ones are these ones. Like you have liquid, that is SLA, and DLP technologies. You have like the FDM, that is what you usually know as fusion deposition modeling, or FFF, that is filament fusion fabrication. And you have like SLS, like powder technologies, etc. So what we are doing is phase extrusion, that is PE modeling, basically. PEM is when you have a material that needs to be in a certain status, and usually like a semi-liquid, like paste material, and hardens by a chemical reaction, or in the most common one, it dries up. For example, this is or you have seen like all around, like the house is full of clay things. It's basically we print a lot of with clay, concrete, and today we will also do like potato printing. Potato, smashed potato printing. So just because it's slightly cleaner than clay and it's easier to mix. So the rule is if you can, it has more or less the consistency of toothpaste, you can print it. That's the rule. Of course, there are like more things in between, like if the material has a little bit of cohesion, for example. Ketchup, when you use like shake it and you squeeze it, it makes a blob. It doesn't get all through the plastic. It's like gets its cohesion has a cohesion between itself. So the plastic box is clean. It doesn't all the plastic cover is not become red like other materials. For example, oil. All the container of oil has oil. In the ketchup, it just stays like a blob. So actually, that consistency, like that is like glue stickiness on the material, is quite important. So the principles that we are using is going to be really the same as fusion deposition modeling. That is the traditional plastic extrusion. Plastic extrusion works by heating up the material. That is a hard plastic. That is something that you have here. Plastic that is called a thermoplastic. So basically, it depends on the type of plastic. You heat it up, melts, and it solidifies by cooling down, losing the heat. In our case, we have some constraints. As the material doesn't dry up immediately, or in this case, the material that we are using, this clay, takes at least 24 hours to dry, you cannot produce super large objects at once because the material is fluffy and basically it collapses on its own weight. So in the scale that we're going to work today, that's not a huge deal. But you have to think that, for example, these big towers that you see on the door, they were printed in batches. So half of it was printed one day, and when it was a little bit dry, they print the second part on top. It continues, but they stop the printing at mid-print. So we have the same principles, and we work with making 2D layers. And just so we don't take like thousands years of printing, because clay extrusion usually need to do way slower because the material doesn't cool down, it's always fluffy. You need to print slower so it doesn't move. Because if you print really fast paste, basically you drag the material. Like imagine trying to print jelly. It's actually the same. What you can print, as I say, if it has a toothpaste consistency, you can do it. For example, the smashed potato has a good consistency. It's a material that is more or less hard, but has a problem. It's not doesn't have cohesion on itself because it's grains mixed with water. So what we can do to improve the performance of the material to make it easy? We can have additives. Common additive for like biomaterial printing could be agar. Agar is a structure from algae that is like a thickening agent. You can also use glycerin. Glycerin basically helps a lot with the cohesion. Or you can use xanthan gum. Xanthan gum actually is what makes the feeling of the ketchup. Is that gets like gummy aspect and the gummy cohesion. So you have like xanthan gum or blah, 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 blah. Depends on that. You have different additives. Actually, all of them they are there to help to get a little bit more smoothing on the material, to get a little bit more cohesion, to make it a little a little bit thicker because maybe your material is too liquidy. For example, Nutella is a really easy chocolate. It's more or less a quite easy to print material. You have a backup that is you need to heat it up, and you only have or working time the time that the material is still hot on the cartridge or the system. And when it gets cold, you will get a jam. You could solve it by making this cartridge a little bit hot with a heating system that doesn't get too high. Yes, but you need to mess up a little bit more. So we try not to print with heat-assisted things, just because it's less messy. When you try to print, this is the printing. Let's go. Printing preparation. What is? ¿Qué cámara es?
No, the problem is that I think it's 6 meter long cable. We are losing a little bit.
Mogollón. So there are a lot of different ways of working with face printers, and there are companies that actually they produce and sell like face printing. They call it usually like ceramic printers because it's what most people use this technology for. The most common is like you have the Delta Wasp. Wasp is an Italian company that produces ceramic printers. And other one that was 2 years ago a Kickstarter project is called Cerambot. That's not that common. Like, and you have like Worm 3D that is like the most professional. They make also the printer. Why? Because it's not as straightforward to adapt a printer if you want to have like large printing scale. Why? Because you work with cartridges of material. These cartridges are really heavy in general. For example, this cartridge is really small. We work on small scale. This cartridge is 200 milliliters. We have 300 and we have 500. Over here, we work with large ones. These ones that we make custom. This one we assemble ourselves. It's a and we can make it as long as big as we want. What happened? We start using these ones because we have a risk. To push the materials, we use air compressed air. Air compressed for a motor. We have a motor, so we don't need air compressor, but still we need to put a lot of pressure in the material. And pressure could be really dangerous. Face spring, in general, you can use between 2 to 11 bars. Like, and in general, you use more or less up to 4-6 bars. Below that point, above that point, becomes really dangerous. Because if, let's say, the cap explodes or the cap just bounces up, it's more or less 300 kilos per square centimeter of force. So imagine this flying at 100 kilometers to your head. You don't want that. And actually that happened. The thickness, exactly. But that's, I want to talk first about pressure. So you have the cartridge, and if you don't assemble well this cartridge, you need to be careful, like use put glue epoxy, like high quality, put safety screws, etc. So a lot of students were not really careful or like not conscious. So we have a few explosions of cartridges. Luckily, nobody got injured, but this actually flied away. Like in the other building, fly like 20 meters. Like a bullet, like it's a rocket basically. So we jump to a smaller ones. That's a little bit more if you want to print large scale. But these cartridges are industrial adhesive dispenser cartridges that are like safe, like industry safe, up to 6.5 bars. And in general here we don't go below 5 just for safety. For example, have you seen the big extruder of the road? Like the large plate one, that one reaches 10 bars. But that one is steel and aluminum, and it's another game. But the concept is exactly the same. So, and also filling up these cartridges is way easier than filling up the other one. The other one you need to make a lot of material to actually produce it. What pressure do you need? Depends on your consistency. For example, if you make, let's say the clay, because it's a material that we will have right now here to show you. If you put a lot of water, the clay is really easy and it's like Play-Doh. So you don't need a lot of pressure. If you don't put a lot of water, it's really tough and you need more pressure. What's the balance? That's the point. Drier the mixer, more height you can reach because it doesn't collapse, because the material is stronger. But also you have more problems for extrusion. For example, in that one, they use a lot of pressure because you cannot print more than 30 centimeters if the mixer is not really, really dry. In this scale, you can print bases like this with double liquidness of the big extruder, just because with this different scale. In general, you will say, okay, this is confusing. What is the proportion? And here is about experience and testing. There is no golden rule for the material. Like it's no golden rule at all. For example, see. These are little pots of lactose. This is milk. with vinegar. So you mix milk with vinegar, the lactose, the casein separates from the water, and you get a Chamarro material that actually is how the old foams, like the bakelite foams, is the raw material that is used to make the pre-plastic generation of plastic that we have right now. Is the initiator of plastics, is this one. So this is impossible to print, but adding like xanthan gum to this make it super easy to print. And you can make prints. What happens? It's a material that when it dries, retracts a lot, and this kind of thing. So depends on the material. You need to account that the material will change when it's dry and when it's liquid state. For example, clay, dark low fire clay, retracts 5%. Porcelain clay retracts 10%. So if you want to make 100 millimeter cylinder, you need to make it 110 diameter. So when it dries, actually gets the size. Materials you can print. This is literally liquid. This is printing liquid with the same system. What happens when you print liquid? You cannot print liquid. So what you can do is put it in another material that has more or less the same density, but it's a different material. We do it in the other building, not with these printers, but we can do it with these printers too. Yeah. Yeah. So let's see. For example, this is the resin of the SLA that is completely liquid. It's like watery, like oily. So this you cannot harden at the moment. So what you can do, for example, do inkjet printing. You let the liquid inside another material that has slightly more consistency. So actually the material stays floating in their own position. And what you do later is so you let the liquid and then you harden it. In this case, it's a like small like fish container. We put it outside because it hardens with just natural light. Or as this is blue because we're using like UV LEDs to harden it. Actually, 2 years ago, there was a student of NDS that did it. And what you do is, it was printing and have a pump filling up with water at the same speed that the height of the print. He had problems to calibrate because it was like, you need to know the amount of time you take to fill up the water at the same time. So actually the water helps to, at the same time, cool down the resin so it hardens faster and keep it balanced. You have the problem that to make the colophonia, like the fine resin liquid, you need to heat it up. And that means you have a working time on the cartridge, unless it's not assisted. 3 years ago, there was a student that actually built his own extruder that was like 2 meters long, aluminum pipe like this with a lot of heater bands to actually heat up the cartridge. It's in you can see it's Elliot Santos Ajax block.
What did they use the
It's there was a really experimental project to like 3D print construction materials that can get colonized by mycelium. Mycelium is a type of fungus. Yeah.
Okay.
Not really useful. Like didn't get to make like any proper like shape, like cylinder. It was like very organic shape, but it's still. Well, no, I will help you later. So, yeah, okay. So in our system, we have 2 different types of machines. In our case, like the machines, you can use a standard like 3D printer. What you need to do is make more or less modifications. We have 2 different systems. We have this that is the COSEL, that is a Delta printer. Theoretically, Delta printers are better, faster, and everything. For paste printing, it's not exactly the same. Why we have 2 different models? For example, in this one, the cartridge is mounted here. so the cartridge is heavy. That means in normal printers you have one motor for the Z. In Delta you have 3 motors. So it's really common to see like Delta printers with the cartridge immediately mounted because you have 3 motors to hold the cartridge. And even so, when you switch off the printer, usually and back to school, this goes down because of the wrong way. In this case, we are using direct cartridge printing. So what we are doing is we have a small compressor here, and we always have a manometer that is to regulate the pressure. What is the pressure? You always need to test based on your mixer. So you start increasing you always start with lower pressure, and you start testing. For example, right now the pressure is on, but I don't see print quality or like material. So I increase slowly the pressure, and the material is going to go faster or lower, and I release and stop. This is a 3-way solenoid. Basically, like the water hose, close and open, but it has 3 ways because when we stop, we release the pressure. Sounds like the roller coaster, exactly the same. Why we need to release the pressure? Because if we keep pressure here, the material will still flow. So we need to take out the pressure. And this is something that in printing, when we print, we need to account. When we switch on, it's not immediate. It takes like half second to acquire pressure and start printing. And when we finish, we release and it still has a little bit of pressure. So we need to wait like 300 milliseconds, more or less. And this depends on the consistency of the material. So base printing in general is easy. Get good quality of base printing, that is the tricky part. Because you need to see what material, if you make another material another day, you need to have the same consistency. And that means you need to be like kind of scientific in a way that you take 100 grams of clay and I mix like 5 milliliters of water. And you have to mix it really well. So this clay, the brown clay, we mix around like at 10%, 15%. But for example, the other day I was printing porcelain clay. Porcelain is way thinner and way smoother. And I was mixing at 5% water. With potato, this is the first time we printed potato was 2 weeks ago. So just we wanted to test. And it was printing quite well. Bioplastics. So we did, for example, this is a pyramid made out of potato. And it was getting really nice consistency. So you see, for example, this is agar we put something or this glycerin. This is the video. Yeah. Potato, smashed potato, water and glycerin. Yes.
Is that for the people for all?
For
all the tests.
So, for example, you see that we were printing the accelerator, and you have seen that here the material has lift up because it doesn't get hard in the instant. So you need to usually we print quite slow to get good quality. We are improving and we are kind of modifying a slicer that is a traditional 3D printing program that you put your 3D model and does everything automatically. We have it. This cube was printed like that, but it's still not the best. So for now on, maybe later on we will explain like how to use it, but now we will stick with Grasshopper. With Grasshopper, we developed our own custom script and we compress in blocks. So most of the part is hidden. You don't need to play with a few parameters. The other system that we can play with is, in this case, we have the direct cartridge. What are the benefits? First, it's super clean and fast. We just fill the cartridge, we mount it, that's it. To clean, we just clean the cartridge. What is the platform? When you fill the cartridge, you have air bubbles, and it don't mix really well. What happens with air bubbles? You have an air bubble here, the air gets compressed to the temperature that you have in the compression zone. This is a filter. So when the bubble reaches the point, it has air and high pressure. So it basically breaks up the thing. It makes a block. Like this. Sorry. So you're facing this super nicely, and suddenly a bubble of air that is really common happens, and basically blow up your print, destroy it. So this system is really nice for making material tests, or if you mix the material really well. If you mix the material really well, you will not have any problem, but you need to be careful. And next, on the second, third time, you will start knowing how to mix the material properly to avoid the bubble. So here, for example, we have the breaker of the field. Ultimately, where is the ignition? Actually, that will be the line. For example, this is printed with not even like 1 millimeter nozzle. This one is printed with 6 millimeter nozzle or more. And you have to take into account that when you put material, what happened is the material settled. So, sorry, like, I messed up with it. So, if you have a hole of 1 millimeter, the paste is going to go a little bit on the side. So, a 1 millimeter actually is a 1.2. A 3 millimeter actually is a 3.5 in general. So, you get easily than 10, 20% more of the nozzle diameter for printing.
And obviously, the thinner the nozzle, the more pressure you need.
Exactly. The thinner the nozzle is having more pressure. For example, just before, this nozzle was like 1 millimeter, and this cartridge has been here for like 2 weeks because we didn't keep it. So the clay is way drier than it should be. So I was reaching 6 bars, and it was not extruded. I just cut it, make it double side. Right now it's 3 millimeter or more, and now it's 6. With, like I say, 4 bars around, no? Right now. Yeah. So 4 bars is quite nice. So this system is cleaner. Well, this one is more nothing. What is the difference? So we have the same concept, that is a cartridge attached to this blue part, and in this blue part we have basically a screw. That the screw, oh, let's go well, the screw goes inside, and basically the screw doses the material.
What's the material?
The material is getting dosed. So the cartridge is all the time at full pressure to fit here, and what actually controls extrusion is the rotation of the screw. This screw is called a degassing screw, because by compressing the material on the thread of the screw, the air bubbles go up and the material goes down because of the screw geometry. And this actually makes all the difference. It makes a huge, huge difference having this. What happens? Every time you finish, you need to take out the motor, clean the screw, be careful that the clay doesn't get in the motor. Like you have the idea, the guys of the OTF that they print the whole here, they are already, each group at least have destroyed 3 motors and like 6 of these, just because they need to clean and destroy, and they do it every day. Like this is in-house design, and we just produce it here, we just print it. This is good, and you get really good quality. And you can change in this design. We can basically stop. And we really think we make small modifications to match this printer. This printer, we have different models, and we can print different nozzles. For example, if you want, you can do a star nozzle, like a little bit useless, but you can do it. This one, for example, is 3 millimeter. The bad point of this system is when you finish, you need to clean it all the time, and it's super annoying. Actually, the worst part of paste printing is cleaning up cartridges and cleaning up. Like printing is super clean in general.
What did you call the screw?
Where?
What's the name of the screw?
Degassing.
Degassing.
Degassing. Degas, like take the gas out.
Oh.
Degassing. Hmm? Because in the plastic extrusion, the plastic is fed by a system. Um, so the pellets fall by gravity and you compress them. In case of the pipe materials, it doesn't fall into some way. It's too simple in general. If you want to have the consistency, you can. So that's more or less a little bit short-term history. Like, and what we will do is produce. This is the system that in general is better and is more accurate than with that one. That is, you can make really nice quality print if you are like inverted after like tons of things they do every day. Just go after they have the same system there because they want to explore really well and they basically is the best. So they want to have the best system. Huh? It's the OTS, the Open System Fabrication. The guy that basically the clay printing. The clay printing guys. So for this we use decode. Decode is how the machines move in the line of that basically is like GPS coordinates. Like you have G's, different G's, G1, G2, G3, depends on what you want to do, and you have the position. X10, Y10. So the machine, let's say, if it starts and wants to move to this position, will be G0, X7, Y18. And the machine will move to this position. In general, you have different types of movement. You want to do faster movements or slower movements, and you can also stay the speed. In 3D printing, we have something that is called the E. That is basically how many turns of the motor you need to actually extrude the material. G code. The G is F.
What
F feedback.
what
And that's why I don't want to get too technical today, because we will go over like the second week of the academy, the third week of the academy, the fourth week of the academy. Let's say today is about playing and getting used to how to use it. Let's open the black box in January. No? So the script we're going to use is something similar to this. Because we have different machines, we need to be able to customize them. So first we have the printer geometry, that is basically the workspace of the machine. If you want to use this one is a delta printer, and that one is a Cartesian, because it moves in like 90-degree movement. Y, X, and Z. So in this case, you can configure, for example, delta. Yes, it's a delta. And adapts already the geometry, like this is the values of this thing. Because we always use this one. In case if you have another printer or you want to use another printer, you can also use it. So here we can, for example, create a base. Let's say polygon. I will use this polygon of 3 types. I will lock. Then you can do it by hand or with grasshopper. That is the thing that we did last day, the bases. Okay. And I have this geometry. So this is a super basic slicer. So what we do is spiralize. We don't make the interior reinforcement. Geometry. Set the geometry. Okay. And we connect to where it needs to be connected. Let's do the bifocal. And it will automatically place the model inside and make the cuts to print. It's a super simple slicer. Let's say we use only for spiralizing. Why? Because a lot of people, and usually what we do is like we build our own extrusion by making lines. So basically, you draw the lines that you want to print. Let's say I want to draw the shape, and then you copy them to make it directly the movements of the machine. You don't define the geometry. If you want to have the geometry like this, without getting too crazy, we can only do spiralizing. Spiralizing is something like this. I have to show you a WhatsApp. Copy just my computer. Ya va, ya va. So for example, this is spiralizing. Basically, we define the shape, this wavy, and then we cut it. Having the base is easy to have a base, but designing the interior reinforcement is slightly more complicated. So let's say for now on, like you're really good at just copper, thing that you can make bases is really simple. Go a little bit beyond that, slightly more complicated. But for example, all these samples there, that is not, they are not bases only, this MDF students from over here. This one, I don't know why, but this is kind of sour. So basically, they designed this as a circle with a lot of offsets at different heights, and then we got it to geometry. So basically, we got all the lines to dimension of the movements. They didn't design the object, but literally the movements. Here. So what this does is basically centers the geometry on the print platform, and this one is the slicing one. This is what cuts. That's why I will do the icon slicing. So here we need to state what the layer. What is the distance between the layers, like the cuts? How high is each cut? With a 3 millimeter nozzle, in general, the rule is like you use 20%. The maximum slicing height is 20% less than your nozzle diameter. So if your nozzle diameter is 3, your maximum layer height is around like 2.5. If you want to stay safe, it's 2. Right now, I cut by hand. I don't know exactly if it's 3 millimeter. So I'm just going to say like 1.5 for now. The nozzle diameter right now should be around 3. And this is the Z-bed offset that we will go later, and this is really important. Why? Because we are changing the points every time, the nozzle. And one of the bad points of face printing is it's not like 3D print, normal 3D printing. Super messy. That when the printer finish, you can take the model out. You need to wait for it to dry. So what you have to do all the time is putting a surface where you can print. And this is by experience. People just put here with the first thing they can find in the trash can. So that's why we have the Z-bed offset. That is to measure the thickness of this and add it to the bed, so the nozzle doesn't crash on the bed. And this we can measure it, and we need to introduce a value here. We have other values, like for example, like the jog speed, that is the movement in the air, how fast the machine moves. The print speed, that is the printing speed. This is a value that you can play with, but let's say I always try to print in the standard. Like I don't get to printing speed, I go more slow, like for 90% of the case. And we have the student multiplier. That is, if we want to increase the amount of material being deposited by increasing like a multiplication factor. So you want to extrude more, you can increase the multiplier to push more material in the same amount of time. Let's say right now we have like for each millimeter, the motor rotates like five steps. If you want to move in 1 millimeter, 10 steps, you will have more material flowing. So the line will be thicker and you can print higher. In this case, this machine doesn't have the motor. So we need to use only presses. This will toggle between motor and like the system that the three-way solenoid, and it does automatically. Let's go. It's too much right now. A little bit. Let's go. I will do one workflow and we'll repeat with you again. Okay. So how we control the machine? We use a repetier, that is a software that allows to directly control the machine. So the machines, we don't print with a USB, sorry, with a SD card. We connect with a USB. As you see right now, I have the other printer. I change the program to choose the other printer, config, printer settings, printer. Okay, I connect the machine, go to manual control and home. The machine knows where its home is, so we can move slowly until to measure where is the touching contact on the surface we want to print. We can also control the extrusion here, that we do it with the fan. So the machine is going to be all the time doing this. And you see that the cartridge, you see the pressure. You can. You need to modify a little bit the speed, but you can. You see, it's super high technology, like printing on cardboard with double plastic. So what I'm going to do is going down to measure the position, and I can click here the position. I will do it manually, right in the code because it's faster. We will have a class specifically on how to talk with the machine today. Okay, on how to send the command. Seems now, like so, the set is minus 26. This is the value that we need to set up here. And right now it's in positive. So we just put a negative and 26. And you see that the model will move that. It's not? I don't understand. No, if I change my Rhino, I don't know. It will update automatically more. I just choose the other line. Everything updates in Grasshopper because I have reference. No, we are actually we are not in Grasshopper and we put in Rhino. What we do is we can draw in Rhino or Grasshopper, and in Grasshopper we produce the code for the machine. So what else we have to do? Actually, right now I just want to be sure that I'm using pressure, and between the on-off is going to wait 150 milliseconds. The scope is okay. This is the code that the machine has to follow. So what we're going to do is just copy it, copy data only, and what we're going to do is paste it on the control software of the machine. Where we need to paste it? In print preview, edit G code, and we just paste it. And we can see that it's going to start in the line minus 24. Why? we state like it was minus 26 because we had the first layer thickness. Exactly. So it's already accounted for it automatically. Let's try to print. And in manual control, I will state that the speed, let's start at 50% of the speed because I need to calibrate the amount of pressure so it flows enough material for the speed I'm using. No, tiene presión, pero you see it's too much, too many pressure. I have to reduce it so I don't print too thick. Because I didn't test it before. And like getting it the first time, the first value is usually like, let's put it 100. So now it's no pressure. So the other machine works almost the same. So the script works for both machines. We just need to change one to select air pressure and the other one to select the motor. And we do the same. We connect with USB, we copy the cables and everything. So if you want, what you can do is let's leave this machine printing, and like one of you install the program. I send you the grasshopper, and you can do it everything like show the rest of the class how to do it. It's okay.
Here, I have the living there, it's and then moved up insert the for like so instead of what do you do best if they just kept going more and just move
And that is actually what the guys upstairs investigate and they spend like 9 months doing. It's actually the point of the year is how to get the most out of face printing and get these kind of fine details. There are a lot of styles of printing. You can do like this, go up and come back. It's called the zigzag. For clay, it works really bad. But for example, for milk, works really well. You have right now embedded, you can see that is like moving back, up, down, cleaning, and go again. This is something that the guys added because they show that cleans well. Right now, the machine is not calibrated and the pressure is not good enough. For example, in this case, it doesn't even have a joint point. Everything is a spiral. It's like sprint. It's a continuous line. Producing this path is the best one, but it's grasshopper wise is way more complicated. You can make transitions. For example, I can show you where I have it. Let's go grass. Isn't that one? It's the best one. It's the best. For example, I will show you this. This is a script that actually spiralizes. This the same one, but I'm experimenting with it, and like this version is the 6.1. Like this is we have made like it's with this script has already 2-3 years, and we change it every week. So let's, for example, put this one. So one geometry. Repeat it.
Someone already installed the repetier.
So, for example, here.
Yeah, if it's not, we will not be able to.
Ahora vamos a ver.
O lo vas a hacer con cura.
No.
Repetier.
Look, this guy. What is it? You see these lines? It's actually the transition line between layers, so it's a continuous one. Make it that, grasshopper wise, is adding more or less this. But this script we are changing every day. And actually, since, for example, since September, we have improved it a lot and now automatized all these kind of things. For example, here you can see the base is automatically created. So probably at the end of this year, we will have like a material, no? So let's kill this. Kill. Dale. Presión. Yeah, right. Another bad point of the system is, I always state the bad points of the system, but actually most of the times is the one that I use because it's clean. The pressure when the cartridge is full is different than when the cartridge is empty, almost, because there is less friction on the material. So when you are getting the cartridge empty, you need to reduce a little bit the pressure. So this system, you need to be a little bit more all the time depending on the machine to adjust a little bit the pressure up and down. The other one, you can keep a high pressure, and what actually makes the dosage is the screw. So let's say it's a worryless system, more worryless, still you need to adapt a little bit sometimes compared to this one, but this one is way easier to use all the time. If you want, what we can do is I will disconnect my computer and you can use both machines. Let's first fill out one cartridge. Still have time, don't stress. We have 1 hour.
Less because I have to go to the studio and we cannot arrive late and it's not going to be our fault.
Just to give you an idea, I printed last week. Last week I printed all these cups in one afternoon. Actually, this is all my family Christmas gift.
Wow.
You make extra ones for art.
I already spent all the clay. Okay, so please, two of you install this one. There is Mac, Linux, and Windows version. It's called Repetier Host. It's the program that we use for controlling not only these machines, but this you can use for controlling every 3D printer. And also that one. That is the machine that we will show you how to use, that is for experimentation. The big one that is up in the top of the shelf. Repetier Host. You go to Repetier Host and you download this one.
Can you send us the link in the chat, please?
Sí. Did someone ask something, please?
Yes, hello. I just
Yes,
was
hello.
wondering if you can share the link in the chat.
Yes.
Thank you so much.
Chat. Mm-hmm. I actually think that sí, obviamente.
Cuando te conectas, te pone repente code and the open ecosystem and identity developer. Había que entrar en el sistema o algo así.
Si lo haces, botón derecho. Ahí está poniendo como writer de instrucción.
Creo que yo sí estoy trabajando en cambiar para transferir instalar access to the security so that they don't compare
Actually, guys, I'm gonna give you. I will send also in the chat the grasshopper link, the grasshopper file. File, computer, and so these cartridges, they have one peculiarity that is when you clean, you need to be careful that they have a rubber thing over in here. That is really easy. In fact, this is difficult to see, so it's really easy to miss. Like you lost it, you can try. It's usually that it's on the other. And right now, for example, the pixel is up, or let's say you have printed, how you can take it out? It's difficult. You have to be careful and not going to someone, but you use air pressure to fire. So I will bring the pizza in.
Half a liter.
So yeah, have you installed Repetier? Okay. Tell me when you all have installed because we do a little bit of configuration for creating the mosquito. So the configuration is just visual. You can control like with the square thing that you can control the regular one, but it makes things easier.
I would say that we just
So they want to go to one of them. For example, guys, this is a student doing. ¿Qué pasó? Se ha ido la conexión. ¿Eh? ¿Se ha muerto? ¿En serio?
Te estamos escuchando.
Sí, sí. Like Google doesn't work.
Problema de conexión. Te estamos escuchando.
Sorry, could you repeat this?
Yes, we are hearing you, so it's not a connection problem. It's not an internet problem.
No, it's Google. It's Google. That hold on.
Actually, I had a question. I'm not sure, but I think that sometime or I don't know exactly who, but they told us that we're going to have a 3D printer for each one of the students in a pack.
What? They're asking that someone told that they're gonna have a 3D printer for their own. I guess suppose they are talking about the 6-pack. Who says this? I don't know. Who said that?
At the beginning, I'm not sure if it was Chiara, but I'm quite sure that they told us. So,
Santi?
We did last year, no, we planned last year for the lockdown.
For the lockdown, we did last year.
It was not a, it was, I mean, it's not a thing as you are.
It's not a 3D printer like this one. It's actually like.
I don't mean this one. I just meant even if it is a toy, I think it can help to learn.
Like we have to talk with Chiara about it.
Okay.
I was going to show you like images in Google, but like the presentation, but they need to go to the, like for example, this is orange peel. This is orange peel. This is coffee beans. You see, this is really bad material for printing. That's why it's on flat. At some point here, we have Nutella.
Nutella.
Yes. In the lockdown, I ran out of plastic at home. I don't know if I have in. So I had Nutella. So I just made a strudel for Nutella from my house printer. Okay. Okay. So guys, connect to the machine. Let's go over the configuration of Repetier. Guys.
Okay.
So Repetier, we need to configure a few things. Basically, it's like the machine that we are connecting. It is Delta or Cartesian, and the protocol that communicates. Luckily, most of the printers connect the same way. People is talking. So someone connects to that printer, and someone connects to this printer, please. I don't know. They need to find something. So, guys, how to set up Repetier? You need to go to configure, printer settings. Yes. And here you have the connection. That is the port. The port is called a serial port. That is when you connect the USB of the computer, of the machine, it needs to recognize it as a port. It's called like that. You can set it in auto, and the baud rate is 115,200. Here, look at the screen. Auto. Just let it in auto. Usually works well. Está pegado. Quítalo. Os paso el otro que no tiene plugin. So printer settings, in configuration, printer settings, connection, auto, at 11 115,200.
Okay, so that's it.
Okay, nothing else. And we need to go to printer shape. And here is where you select the type of printer, square or delta. And these ones are classic printer or rockstock printer. Rockstock is actually how we call deltas. Deltas are not called deltas, they are called rockstock. The port, because you are not connected. Just let it auto, it will automatically recognize it. So in your case, you need to select rockstock, and in your case, you need to select classic. Classic, that is square printer.
Down area. Down.
Yes.
If one can put the measure, but actually the measure has
So once you have that, what happens is you need to connect. You see the little plug on the left top? Now you have plugged the USB to your machine? Yeah?
Yes.
So you need to know if you are going to be able to connect. So you click on connect, and I don't have the machine connected, it's not connecting. It might not connect in your computers. Why? Because we need to install the machine drivers. Right? Depends on the computer. Depends on. It's connected. Okay. So go click on home to see if you are connecting properly or not. So print panel. Wow, this is really different. The mad one. Yeah. Oh my god. Oh. Yes.
What are you waiting for? Without your rhino.
That's it. There you go.
And then you can also take them this if you want to take.
No, I have. You have basic.
No.
Okay. So okay, so now put it properly and go on the set lower to measure the height. Okay. We know already that it's -26, but play a little bit by moving the machine.
How do you stop it in case like it's emergency stuff? Oh. So let's try Z -100. And like it's moving, but that's really no. Yeah. It's moving and then it's now once you have set up the command, it's going to be so that is right now it's using usually in a synthetic way.
Saludan de la cámara, Santi. All the data is in the head.
I'm saying that I'm sure that texture have recipe for the field. It will not be very, it will not be super like maybe it would like
Can you something how we transparent right?
I know it's
No sé,
No. Yeah? No, no way.
yeah, please.
Como venía por aquí, me dio un par y me dijo, por leer.
Pero hay una lista, una cosa más como ver, y vamos a contar. El mínimo, 0. And this is the most delicate part. This connection is going to be weak. So don't forget, you need to be really subtle when you connect it.
Where you still have the pyramid degree,
And the going is so what is the pressure that we need to set? Actually, it takes a little bit of time here to get to realize this because right now all these are examples. So we need to set a file so it fills up this and not bring the pressure. How do you know that you don't have enough pressure? Basically, it doesn't work. How do you know that you have too much pressure? This is a control point, it's called. If the plate is coming on the shaft, and you can see here that this part is filled with material, we need to have too much pressure. This area. So if you have too much pressure, the material will start filling up. This is very two parts to do. So let's send something to three. So let's up. Yes. Let's send so the speed in the map. If you don't want to do this, you can send a file. You start reading, let it play until you don't say anything right. Let's look at it. We are looking at 200. So this is not taking the flow, and it is a little bit of based on is you need to put a piece of cardboard or like anywhere super nice like configured. Place. I send you the grasshopper file. Did the grasshopper file open properly? Where is the chat? Chat. Ala Barcelona, painting master here. Okay, I just send you a new grasshopper file. So the file that you have this right now, this one. So in your case, delta no is a Cartesian. Acabo de mandarlo. Yes. Reset. Emergency stop. Connect the
No, pero estás en otra sesión, ¿no? Porque tú no ves a nadie, ¿no?
No, because it's the same.
Sí, sí. Sí, sí. Ahora estoy mandando.
No, it's minus 25. For sure. Home, did you home? Because it doesn't show here. It only shows when you set it up manually. Oh, so it's minus 10, minus 20, minus 21, minus 22, minus 23, minus 24.
Okay, so how can I see it?
I have a message, unrecognized objects.
Siempre nos quedará un pendrive.
¿En serio?
Ahora yo tengo.
Okay, let's do. Do you have the grasshopper file?
Yes, but there is an error message. It says that undetected files and objects.
Which object? Can you share your screen? What is the error message? Can you close the file and open it again? No, it's that doesn't close the file. That's you need to click on the letters, text, 3D printed master V6. No, just below the corner. Okay, request. Veronica, here, I don't know if I can. Yeah. So here, this is where you can actually see the files. You close the file here. Yeah. This closes Grasshopper. The other one that is here closes the file. Just open this one and doesn't show up error. But you have a warning message is because you don't have a plugin, but that plugin is not mandatory because right now all these blocks they work and you have the output here. So that warning message is not a big deal. Just acknowledge and that's it. Okay? Veronica? Hello? No answer. This, Santi, aquí. Z bed, Z height offset. In the
Estabas controlando mi pantalla y me tenías en mute y no me podía desmutear.
perdona.
Okay, what should I do now?
You can design something. For example, you can, let's say, don't know, draw a cylinder in Rhino or any shape, and
Okay,
reference it in Grasshopper.
okay,
This, set one geometry. You can connect it here to Breve geometry, and it will automatically make the cuts. And you will see here that it's making all the instructions for the machine.
okay. But I think that I will need more than 10 minutes to do that now and understand that, because remember that I just have those super licenses a week or so.
Yeah, that's like this. We are showing you this today, so you have a little bit of time during the holidays to understand like how this works. So
Okay, thank you. Now I know what I'm going to do during holiday. Great Christmas. Thank you. Okay, I will play a little bit and I will try to find some tutorials. If you have some link, please, I will really appreciate it.
is all the links are always. I already sent you all the links.
With the Academy, okay, thank you.
Yes, is where we have all the classes.
Okay. Okay, so we have an intensive holiday.
Make club. Here you have all the files.
Okay,
And actually, you have Grasshopper 101 that is a super nice guy.
okay,
I'm copy in the chat the link just in case.
okay, great.
Done it, no? Claro.
Which file? 6.2. 6.2. 6.2. That's why I updated a 6.2 is better, but like when you build a software, you use plugins to this nothing. But when you want to carry this another one, then you say like you have this plugin. So with this file, what you do is that we use plugins to build a file, and then when you want to carry the document, you start the plugin. Okay, so I have this one. Yes. For example, you can take a So how many was that? There's a millimeter, right? Maybe I'll make it.
Yeah. Start, no?
Okay.
So giving the light waiting is light.
Guys, you have 4 minutes to turn speak up.
Huh?
What am I?
Okay, this is a little bit trick, but this is you can have a little bit. So are you referencing that actually said that most recording the machine sound, meaning different materials, nothing like the synthesizer, actually was making music out of the machine sound. So instead of making their own instruments, like pre-recorded, he was capable of all the sounds of different machines, different everything, and assembled the recording. Slicing here, yeah. Slicing is done. But it's one extremely. So it's half face, perfect. Like we face, you want to have like hot three, and then you want to have a very full breath. But here, for you can move it like slicing on for example, this part is 1.8 on the wing, and the height is 1.5. So we're doing. And it's not like it's not really say what you can get the report one higher than the wing. You need to start making it way slower. Be careful if you have a sharp angle, the sharp angle will be the fall. All the class angle. Really nice. And you know the best thing is, you know, the plastic is bio, bio-based. It's made out of the DNA for polylactic acid. That is, if you take lactic acid and you use a process, it has the polymer of lactic acid. And the potato, 80% of potatoes is potato. They use potatoes, cornstarch, and sugar to produce the plastic. Luckily, we are using plastic, but before getting processed, Right, for example, we
trabajando o no? Nosotros no,
¿Qué no salió? What was the problem? I know this, but it's
Son super ligeros. They are super light. It's amazing.
This will be my You can give it to I'm learning to yes.
Are you gonna bring it?
I'll do another try. No, it doesn't get it. Oh, so I'm gonna go for Alright, let it slide. I'll come pick it up.
Lo paro esto, ¿no?
And this is what it is.